So let's start chapter 3, message.sender, msg.sender. It's one of the most important global variables in Solidity. Let's see. Now that we have our mapping to keep track of who owns a zombie, we'll want to update the underscore create zombie method to use them. In order to do this, we need to use something called message.sender. Message.sender in Solidity, there are certain global variables that are available to all functions. One of these is message.sender, which refers to the address of the person or a smart contract who calls the current function. In Solidity function, execution always needs to start with the external caller. A contract will just sit on the blockchain doing nothing until someone calls one of its functions. So there will always be a message to sender. Here's an example of using message to sender and updating a mapping. Here it is. Uh, we have set the mapping in which we have take address as an index and you enter in the variable the name is favorite number. Update of a favorite number mapping to the store underscore store underscore my number under message to sender. So here we have taken message to sender as an index. The one who called this function uh, ha have the address, have the wallet address. That address will get in message to sender, and it will going to set as an index, and number will be passed as a value. The syntax of storing data in a mapping is just like with arrays. It's same like an array syntax in the way we are setting the values in the array. So what is my number function? In another function, we are just returning the message to sender. The one who is calling this function uh, will get his favorite number by calling this function, because as we see that there is an index of message or sender in it, so it will going to send back that message or sender. Receive the value stored in the sender address will be 0 if the sender hasn't called set my number yet. The default value will be 0. In this trivial example, anyone could call set my number and store unit in our contract, which would be tied on their address. Then, when they called what is my number, they would be returned the UINT that they stored. Using message or sender gives you the security of Ethereum blockchain. The only way someone can modify someone else's data would be to steal the private key associated with the Ethereum address. So put it to the test. Let's update our create a zombie method from lesson 1 to assign ownership of the zombie to whoever called the function. Okay. First, after we get back to the new zombie ID, let's update zombie to owner mapping to store message.sender under the ID. Okay. So there it is. Member zombie to member. Let's uh okay. Here uint is index. So we have taken its ID index and value is message.sender. So we'll know who is the owner of this ID. Now second, let's increase owner zombie count for the message.sender. Okay. Now let's see. That's how we can increase the count of zombie. Here we have taken the address at an index and value as a uint. So here we are putting the address of the one who is calling this function, and the value is just plus plus. Solidity, you can increase a uint with plus plus just like JavaScript. Here it is. Your final answer of this chapter should be 2 lines code. Okay. Yes, it is. Now let's check. Yes, great. So we have seen the method of sender in this chapter, and see the syntax, how we can store the data into mapping, and how we can use owner address, uh, the one who is calling the function address, and put it into the mapping and store it and use it for later. And here we will just storing the zombie to owner. So we have known that this zombie ID is belong to this particular user, and also we are incrementing the count that particular user have X number of zombies. So that's it for this chapter number 3. Now let's move on to the next chapter, chapter number 4.